What's going on, guys? Tutorial here, and in this video we have this special problem sent to us by Mary Solin Mariscal. So we have here a truss with these forces 50 kilonewtons at F and at H and 70 kilonewton at G, and we are asked to find the forces, internal forces on GH, CH and CD. So now, since the only unknown here is located on the right side, the best method to solve this is the method of sections. But before that, we need to find the reaction at E here, vertical, especially vertical reaction, so that we can, as we isolate the right side, the free body diagram of the right side of this truss here, we already know what's the vertical reaction here, and that's very helpful to solve this one. To solve this, the reaction at E, the vertical reaction, and oh, by the way, as we can see, there is no horizontal reaction in this truss, so automatically the horizontal reaction at A, which is a pin, will be 0, and at E, since that is only a roller, the reaction should be a vertical only. So now, if we sum all the moment at A, considering the free body diagram of the whole entire truss, we will then have sum of the moment at A equals 0. In other words, all the counterclockwise moments should be equal to all the clockwise moments. So then, what are the forces that cause counterclockwise here? As you can see, it's only this reaction at E, the vertical reaction at E. So the moment arm there is this 16, since this AB, BC, CD, and DE are all 4 meters. So we will have 16 RE is equal to, so that's counterclockwise, is equal to clockwise moments. So 50 causes clockwise moments. So that's 50 times, this is 4, 4, and 4. And so we'll then have 12. So 50 times 12. Plus, we add this one, 70, that rotates from A, that rotates the truss clockwise. So that's 70 times 8, this moment arm. 70 times 8 plus this last 50. That's gonna be this perpendicular distance, so 50 times 4. So all counterclockwise or clockwise. So now RE is kilonewtons. So now we have the reaction at E. So the much faster way to solve this is to look at the truss. As you can see, the truss we have here is symmetrical about GC, or this line of axis here. As you can see, it's symmetrical. So all we have to do now is just add all the forces that goes downwards, and since only A and E supports these forces, so we will just divide it by 2, since this truss is symmetrical. So 70 plus 50 plus 50 is 170. Divide it by 2, we'll have 85. This is the reaction at E, vertical, and also the reaction at A, vertical. So this is how we get the reaction at A. Alright? So now our next step is to isolate the truss. We will let a cutting plane pass GH here, CH, and CD, and name it cutting plane MM. And now we can choose, either we select the left hand side or this right hand side and draw its free body diagram. Either those options, we can solve for GH, CH, and CD that we're looking for. So to make it a little bit faster, I will choose the right hand side. So I will draw the free body diagram of it. And it will look like this. So our reaction here is 85. And then, since it is the only part here that has force, we will write here 50. So that's 50 kilonewtons, and assume all this as tension. Alright? Because if ever we have a negative sign of that, we can just select the opposite assumption, diba? That is negative, and we assume tension, therefore the correct is compression. So now, what's next step? Next step is, whenever you have diagonal forces, like this one here, this is GH, and below is CH here. This two is a diagonal, therefore automatically it has vertical and horizontal components, alright? While this CD here, since it is only horizontal, it has no vertical reaction. So how do we find the slope of that GH and CH? How do we find how inclined they are from the horizontal? So from the given dimensions, as you can see here, this is 4 right here, right? 4. And here, the height will given with 6. So based on that, we have a triangle which has a base of 4 meters and a height of 6 meters. And then, that's the other slope. Take note that we're getting the slope of this CH right there. So we will use this triangle here. This triangle is to this triangle. We will get its ratio and proportion of its sides. We will have 4 here. Then here, this is unknown. Alright? So why are we looking for this y here? We're looking for y because if we have the y here, it's like that, we can say that this is another triangle. So if we know that the height and the base of the triangle, we can say that the hypotenuse, we can find the hypotenuse here, the hypotenuse, and then the sides. With that, we can now find the slope of them, the slope of this CH, right? So now what's y here? Solve for y, we get the ratio of its sides. So y is to 4 is equal to 6 is to 4. 6 is to 4, right? Or is this 4? No, this is 8, right? This is 4 and 4. So this right here is 8 and this is 4, diba? This is supposed to be 8. So y is equal to 6 times 4 is 24 divided by 8 is 3. Right. So now we have the value of y, and then this green here, that's a triangle. To get the slope of this CH, so we'll have 3, and then this base here is 1, that's 4. So to find C, all you have to use is Pythagorean theorem. So that's C squared is equal to A squared plus B squared, or hypotenuse squared plus leg squared plus leg squared. So if we have 3, 4, automatically this is 5. You can check that out. And 3, 4, 5 triangle is what we got here. And also this is CH, right? To find the components, the vertical and horizontal of CH, say CH vertical component and CH horizontal, we just have to use the sides, or we can use the relationship between the vertical and horizontal, diba? If we have CH here, so to get from this point towards this point, right, we use the vertical component CHV and the horizontal CHH. And with that, we form another triangle. Then after that, we will use again the ratio and proportion. Diba? CHH, and CHB. So how do we get the relationship? So if we want this CHB, or the vertical component, we will say that 3:5, or this one denotes 3 is to hypotenuse, is equal to this vertical is to hypotenuse of this another triangle. So CHV is equal to CH. Or in other words, if we move the CH here, we will have what? That CHV, or this one, equal to 3/5 of CH. Right? That's how we get the vertical component of CH. So now if we want, let's write that CHB is 3/5 of. So you can see, if this is CH, CHB is just a fraction of CH, diba? 3/5 of CH. This is CH only, 3/5 of CH. That's why it's called component of CH. So now if we want CH, we use the side corresponding to it. So it's the horizontal. So we will say 4/5, or this one is to this one. 4/5 is equal to this one and this one. So CH over CH. So that's CH, or the horizontal component, equal to 4/5 of CH. You just move it here, transpose or multiply both sides by CH. So now we've got the components of CH. So it's just 3/5 for the vertical and 4/5 for the horizontal. Alright. So now we have this CH. We're done with the forces. Our next goal is to find the components of GH. So this GH now. Our next goal is this GH. What's the horizontal and vertical component of it, since that force or that member is diagonal? So to find the triangle, so our first goal is to find the triangle, of course. We will use this triangle here. This one. Since that describes the slope of GH. Diba? So as you can see, we have here this whole length 6 meters. Alright, that's 6. And we already know that this height here, a while ago, was resolved as 3. Therefore, we have 6 here and 3 here. This height here would also be 3, right? To have 6 as the whole height. So 3 plus 3 equals 6. So now, what is the base? The base of this triangle is just this 4 here, given. Therefore, GH, so GH has a slope 4, 3, and then since this is 3, 4, this is a 3, 4, 5 triangle. Just found out that the slope of GH is 4, 3, and 5. So now, doing again what we did to this CH here, to find the slope of GH, still with the similar triangle, we will use similar triangle. So this is, if this is GH, then this is its horizontal component, and this is its vertical component. And then we will use the slope of it. So we have 4, 3, 5. So now, if we want again GHB, or the vertical component of GH, we will just use its corresponding side to the known hypotenuse. Again, why aren't we using this 4 here? 3:4 instead. This is because if we use 3:4 ratio, we will have GH is to GHH, which is 2 unknowns. So to eliminate one unknown, we'll use this known here. Alright, we will take advantage of that 5 because we already know what's 5, and here we only need to know what's GH. Alright, so with that, 3/5 is to, so this side is to hypotenuse, GH is to GH, GHB is to GH. So with that, we just found out what's GHB by multiplying both sides by GH. Alright, or by moving GH here. And if we want the horizontal GHH, horizontal component of GH, we use this 4. So 4/5 is equal to 4/5 is equal to this 4 is equal to GHH over GH. And so GHH, or the horizontal component of GH, is just 4/5 or a fraction of GH. Just 4/5 of what is GH. So now, we're done with the horizontal, or the diagonal forces, GH and CH. So we've just calculated what's GHH, and we know that that is just 3/5 of what's GH, and then for its horizontal, it's just 4/5, right? And again, for CH, its vertical is just 3/5 of what CH, and then for its horizontal, it's just 4/5 of CH. Now, since we're done with the diagonals and its horizontal and vertical components, we can now go ahead and find points wherein we can knock down 2 unknowns so that we can solve for these values that we're looking for, right? So this point here is point E, while here is point C, I guess. Yes, it's point C, and here this is H, and then this is G here. And also, let's not forget this force 50 here. There is a force 50 kN acting at point H. Right? So now, I will ask you, where do you think is the best way to take a moment at? At what point? So we can cancel out. So I suggest we will take a moment at point C. Because if we take moment at point C, we can knock down CH and CD. And we're only left with 3, 85, 50, and GH. We take moment at C, or at point C, moment at C, and equate it to 0 to say that there is no rotation at point C, or in this Truss, because it is in equilibrium. Then we could say that 85 times 8, so this is 4 here, the distance, this, we take a moment at C. So this is our moment arm at point E of this 85. So we will have 85 times 8. And then what? We add the force that is also causing counterclockwise, right? Since the only force that could cause counterclockwise aside from 85 here, if we take moment at C, is this GH, right? Since this CH and CD will just cancel out, we could say that 85 times 8 plus this GH, and we have the option, we could break down this GH here or at this point. So here we can always choose as long as it's in the line of action of that force. So it is much easier, or it is easier to break down this force to this point at G, or yes, that at G, because we can knock down this vertical component because it passes through point C, the line of action of the vertical component. So that's another technique there to make your solution shorter and less prone to errors, right? We will have for fifth of GH, or the horizontal component of GH, and its moment arm as 6 away from the point we're taking the moment. So for fifth of GH times 6. So since 50 is heading towards the opposite direction, it should be negative 50 times the moment arm. That is 4 units away, or 4 meters away from point C. So if we plug that into our calculator, so the value of our GH is negative 100 kilonewton, and that is our answer. But then GH should be in compression. So GH is 100 kilonewton, but the opposite sign is positive, and that should be compression. Our assumption is tension, so since this is negative, the correct is it is in compression. So now we're done with the first unknown, which is GH, and our next step is, or what we're going to solve next, is this CH. So GH is done, CH and CD na lang. So for CH, how do we solve CH? We will take moment at E, because you can see this is E here, this is E, and this knocks down GH and CD. And then if we break CH at this point, at point C, all we then have is just the 3/5 of CH. This component only, because this horizontal passes through point E, so it will cancel out because it has no moment arm. So we're left with this force. This 85 is knocked out, so we're gonna left with CD alone, and this 50 of course, 50 and the vertical component of CH. So again, sum of the moment at E, that's 0 equals these two forces. It goes towards the same direction, so 50 times 4 plus this one, 3/5 of CH, and no other forces. 3/5 of CH, and of course its moment arm, which is 8. So with that, we now have the value of CH as, of course, again, negative. CH is 41.67 approximately kilonewtons, and again, this is in compression, right? Again, we take the sum of the moment at E because it knocks down GH and CD, since GH and CD passes through point E. Then we're gonna left with this CH alone and this 50. So here's the component, and here's the 50. This horizontal component gets cancelled, or has no moment arm, so this vertical component only is the one that creates moment about E. So that's it. So now that we know what's the value of GH and CH, the only thing that we don't know now and we're asked to solve is CD. So our approach here is either we take a moment again at any point. It could be at E, at H, at D, at C, or at G. We can do it, but we can also sum all the forces, either it's vertical or horizontal. But I guess the most genius way to solve CD is to sum all the forces in the horizontal of this entire truss, because as you can see, CD is just a horizontal force, right? As you can see, CD is just horizontal. So if we sum all the horizontal forces here, then all the forces that goes horizontally here is just this force, and CD. Do you see any other? I think there's none. There's no other aside from this 3 because this 85 is vertical, this 50 is vertical, this and all of these are vertical. So if we sum all the forces in the horizontal direction and equate it to 0, there's no movement horizontally. Then we could say CD plus this 4/5 GH plus this 4/5, I mean this is CD, I know this is CH here, I'm sorry, this is CH, 4/5 CH and 4/5 GH, then be equal to 0. We already know what's GH a while ago. It is negative 100. So we just substitute negative 100 to this GH, and in CH it is 41.67, also negative. So we must be consistent, right? If we got negative here, as we solve, just plug in negative also to the values. Just don't change your assumption yet here, because this 41.67 should be compression, right? But then since you're saying it's negative, so this tells us that this is also compression. So our assumption is tension, and then it is negative, so it is compression. So we can just say that this is in compression still in here, right? Now solving for CD, we've got, so CD is 113.34 kilonewtons, and our assumption is correct. It is in tension. So CGH is 100, CH is 41.67, and CD is 113.34. So this here is 113.34 tension. This here is 41.67 compression, and here this is 100 compression. That's it for this video, guys, and I hope you've learned something. Thank you so much for watching. Peace out.